Assalamu alaikum. I'm Amna Sattar and in this video I'm going to introduce garbage collection basics. Garbage collection is a form of automatic memory management. It frees the memory occupied by the objects that are no longer required by the program. Garbage collection is required because the storage capacity is limited and it is difficult to do the memory management manually. The programmers may not reclaim memory at all, causing memory leaks, or may reclaim space earlier than necessary, resulting in broken programs. There are many languages which use garbage collection, like Java, C Sharp, D language, scripting languages, and some formal languages. And there are some languages which allow both the garbage collection and manual memory management. There are several advantages of garbage collection. It frees the programmer from the headache of manually doing the memory management. It also prevents dangling pointer bugs, double free bugs, memory leaks, and it also increases the efficiency of programs. While there are also disadvantages, it increases the overhead because the garbage collection consumes computing resources in deciding which memory to free. There may come pauses in the execution because the moment when the garbage is actually collected can be unpredictable. Incompatibility with manual resource management. There are two parts of garbage collection: the garbage detection and garbage reclamation. In garbage detection, the live objects and garbage objects are distinguished. In garbage reclamation, the garbage objects are reclaimed. There are several techniques of garbage collection. I will give overview of some of these techniques. First of all, the tracing technique. In this technique, there is a root object from which other objects are traced. The objects which are reachable are known as the live objects and the other one are considered as the garbage objects. Mark and sweep collection. In this technique, first of all, the live objects and garbage objects are distinguished using the tracing technique. Then the reach objects are marked, and then the objects which are not marked are reclaimed. Then came mark and compact collection. In this, the garbage objects are moved into the end of the memory. Copying garbage collection. In this scheme, the heap is divided into two semi-spaces. During normal program execution, only one of them is in use. Reference counting. In this technique, object has a count of the number of references to it. An object's reference count is incremented when reference to it is created. Count is decremented when a reference is destroyed. When the count reaches 0, the object's memory is reclaimed. Now let's talk about the garbage collection in .NET. In .NET, the garbage collector is implemented in common language runtime. We all know that reference type always goes on the heap and value types and pointers always go where they were declared, usually on the stack. Whenever we declare objects using the new keyword, some memory is created on the heap. The less memory we create on the heap, the less work the garbage collector has to do. When the garbage collection runs, when system is low in memory, memory is too much fragmented and it reaches its maximum quanta of allocation. There is concept of generations in heap. In generation 0, the short-lived objects are maintained. In generation 1, the short-lived objects are maintained and they are served as the buffer between the short-lived objects and long-lived objects. And in generation 2, the long-lived objects are maintained. The objects which survive in generation 0 are promoted to generation 1, which are survived in generation 1 are promoted to generation 2, and the objects which are survived in generation 2 remain in generation 2. .NET uses the mark and sweep collection algorithm with compaction. Thus, there are three phases: marking phase, relocating phase, compacting phase. Here you can see the live objects are marked and the other ones are reclaimed. Many classes need to use the operating system resources such as disk, networks, and user interfaces. These are unmanaged resources and need to be cleaned up properly. To facilitate the unmanaged resources, the .NET provides finalize method that can be placed on a class. When a finalize object is created, a reference is placed in a queue called the finalize queue. This acts as a reminder to .NET that it needs to call finalize before it compact objects. The objects that are no more required and finalizer is not called are then moved from finalize queue to the f-reachable queue. The .NET maintain a thread that checks for f-reachable queue, and if it finds some reference, it call finalize method and then delete the reference. Large objects are maintained specifically. They have larger heaps and larger heaps are not fragmented during the garbage collection. There is also a method dispose in .NET. The classes which maintain the managed and unmanaged resources should implement the iDisposable interface. This function, dispose function, takes a bool variable. If we pass true, it means call from the dispose method. If we pass false, it means call from finalize method. If disposing true, then it means reallocate the managed resources and release unmanaged resources in any condition. Let's take an example. Here, this program, what is doing, it is this program is acquiring some resources, the managed resources and unmanaged resources. Here, here you can see this program acquiring some resources. It is reading from the file and acquiring some unmanaged resources, opening SQL connection. There is a function release managed sources. It is releasing the managed resources using the dispose function, and unmanaged resources are simply released by closing the connection. There is a show data function. Here, dispose method. It is calling the dispose method by passing the true, and then it is calling gc.suppress finalize. This is very important because we have already done the cleanup, so there is no need to call the finalizer. This tells that there is no need to call the finalizer. Then we have the dispose function, and if disposing is true, then release the managed resources, else do nothing and release unmanaged resources in any condition. Then in destructor we are calling the dispose with false argument. In main, what we have done, we have called the show data function using the try and finally block, and then using block, and then we just we have done nothing and just call the show data function. Let's check the output. In the output, try finally block and using block, it has disposed the managed and unmanaged resources using dispose function with the true value, and after that it has called the finalizer. So there is many algorithms and approaches for garbage collection. All high performance garbage collectors are hybrid. Developers still responsible for correct working with memory, and there is no ideal and good for all cases approaches. Thank you for watching this video.